Number 6 is our generating function question. Let's just look at the table there. We can see I've got our first probability of 9 over 25, and that's when we have a 2 there, so t squared. We've got 12 over 25, and that's for 3, so t cubed. And we've got 4 over 25, and that's when we've got a 4, so t to the power of 4. You can see a factor of t squared in all of those, so then I've just got 9 over 25 plus 12 over 25t and 4 over 25t squared. I'm not quite sure how much show that they want after this here, but well, the square root of 4 over 25t squared is 2/5 t, and the square root of 9 over 25 is 3 over 5, and that's all being squared, but that's sort of given to you really, isn't it? But there, that's how you get it. Now, the second one, we've got GW of t, and they've given this is t times by a very similar one, 2/5 t plus 3/5, this time all to the power of 5. And we're going to do loads of core maths on this, loads of pure maths. We're going to try and differentiate this. So we're looking at a product rule. The first bit being t, just differentiating to give 1, and the second bit being 2/5 t plus 3/5 all to the power of 5. Now, in a pure math question, you've not any issue. We do this so many times, don't we? But we've got, here's the bracket, and the power goes down by 1, and we're timesing by this power 5 and what the bracket differentiates to give, which is just 2/5. So we've got 2 there. So what does this thing differentiate to give? Well, it gives those two things times together, which is 2/5 t plus 3/5 all to the power of 5, plus those two things times together, 2t, then that is 2/5 t plus 3/5 all to the power of 4. So there's differentiating it once. We need to differentiate it a second time for the variance. Or should we put the 1 in first? Let's put the 1 in first. When you stick a 1 in all of this, I'll trust that you can figure out that it's 3. And so the expected value of w is equal to 3. Right, but the next bit, the second derivative of it. Do you want to just differentiate that yourself? So this bit here, no problem. 2/5 t plus 3/5 all to the power of 4, because the power's gone down by 1, but times by 5 and by 2. So we got a 2 in front of that one there again. But then you've got a product rule happening from this bit here, haven't you? So trusting that you can differentiate, this is going to give 16 over 5 t times by 2/5 t plus 3/5 all cubed, and we've still got the extra 2 lots of 2/5 t plus 3/5 all to the power of 4. Now, when you stick 1 in that, then that gives 36 over 5. And the variance of w is equal to 36 over 5 plus 3 minus 3 squared, and so it gives us 6 over 5. Look, I'm trusting that you can differentiate this here and things like that. Now, going on, part C, I don't know if I've got room to do all this. This is quite nice. We're going to go for x is equal to v plus w. So that means timesing these two things together. I think I'm going to need some more room. Yeah, so really all I'm going to be doing is timesing these two things here together. So the generating function for x, is this an x? This is an x, yeah, is going to be t cubed times by 2/5 t plus 3/5 all to the power of 7, because we're timesing those two bits together. So there's that one, 2 marks for that. And now we're going to go to y. Now y is 2x plus 3. So to do a generating function for y, first thing I'm going to do is times all of it by, well, first of all, replace every t here with a t squared. So I've got t squared all cubed times by 2/5 of t squared plus 3/5 all to the power of 7. That's that bit dealt with. We also want to add 3 to it. So that means that we want all the powers to go up as well. So I need an extra t cubed out of all of that. It does say in its simplest form. So I'm looking there, that's t to the power of 6, 7, 8, 9. And then 2/5 t squared plus 3/5 all to the power of 7. So find the probability that y is equal to 15. So how are you going to get a 15 out of all of that? Oh, this is lovely, isn't it? So we've got 9 of them there. So we got that times by, we're going to need 6 of them here, aren't we? So 6 of them here is the, we want this to the power of the third one of those, don't we? So we want 2/5 t squared cubed. We're then going to want 3/5, it's all to the power of 7, so that's to the power of 4. And we've also got the number of ways of doing that, which will be 7 choose 3. So I think I'm tapping in that. 7 choose 3. Yeah, there it is. 7 choose 3, 2/5 cubed and 3/5 to the 4. So it's giving me this value here, or as a decimal, 0.290304. Oh, that is so nice. Getting some first year binomial expansion into that. Isn't that beautiful? Love that question.